Waiting for R.M.D. ன்ட்டு வருது. Jaykumar sir?
Please wait, ma'am.
Live அப்படின்னு வருது சார். Okay. This meeting is live streamed.
Glory, ma'am, you can start.
Good morning to everyone. On behalf of R.M.D. Engineering College, it is my absolute pleasure to welcome you all to this 22nd edition of this Generic Talk series. Today, we delve into an exciting and transformative topic, Generative AI overview of RAG and LLM. Today, we are honored to have with us Ms. Mansi Jain, Senior Manager, Data Science, Cognizant Technologies, an accomplished expert in the field to guide us through this exciting topic. Before we dive into the talk, let me take a moment to introduce our resource person. I now request Dr. P. Erumalai, our head of the Department of CSE, to welcome today's speaker, Ms. Mansi Jain. Please, sir.
Thank you, madam. So, good morning, everyone. I welcome today's resource person, Mansi Jain, my dear faculty members, students. Today, we are having generic talk series, 22nd generic talk series about the topic Gen AI overview of retrieval augmented generation is a technique that enhances a large language model LLM by integration with the external data resources, improving accuracy, relevance, and contextual understanding. So this topic is very hot topic today. So we after completion of this generic talk, so we will be have new idea technology what is going on Gen AI. So we can is a opportunity for upskills ourselves. So I request every one in this meeting to listen this, make this event successfully. I welcome Mansi Jain, Senior Manager, Data Science, Cognizant Technology. So over to you, ma'am. Hamlata, madam.
Thank you, sir.
Yes, ma'am.
Thank you, sir, for the warm and gracious welcome. I now request Dr. Hemalata, ma'am, Professor of CSE, to introduce Ms. Mansi Jain. Please, ma'am.
Thank you, Glory, ma'am. Now, at this juncture, I invite Mansi Jain, ma'am, with great happiness, and I'd like to give a very short introduction regarding her high profile. She is having around 13 years of experience, including 11 years in life sciences and healthcare domain and data science, generative AI. Ma'am is a global leader who has collaborated with clients and teams across US, Europe, India. She has a year-long stint in Chicago. She is an expertise in generative AI extensively, encompassing developing scalable chatbot solutions, fraud detections, sentiment analysis. Additionally, she is having a strong background in machine learning algorithms, predictive analytics, forecasting. This has enabled her to develop innovative and scalable solutions. Her skills also include cluster analysis, promotion response modeling, analytical insight generation, and project or program delivery management. She is an excellent person in stakeholder management and agile methodologies. She ensures effective communication and collaboration across diverse business environments. She is highly capable to lead teams and manage fast-paced projects, still maintaining high performance standards, and has been demonstrated throughout her career. She is well committed to leveraging a deep expertise in generative AI and related technologies to drive impactful solution, and deliver exceptional results for her clients and teams. We welcome you, Madam. Mansi ma'am.
Thank you, ma'am. Let us all tune into this session with an open minded and eagerness to learn. Miss Mansi Jain, ma'am, we are eagerly looking forward to your talk. The virtual stage is fully yours. Over to you, ma'am.
Thank you so much, Glory ma'am and Hemlata ma'am, for giving me this opportunity to present to the students, share my thoughts, what is going there in the market as of now, why generative AI has acquired the market in more or less almost all the domains. Apologies, my throat is a little unwell today. I'll try to be clear. Um, I'll quickly bring up my screen now.
Ma'am, can you switch on your camera, please?
Yeah, ma'am. Give me a second. Is my video visible?
Yes, madam.
And is the screen visible?
Yeah, madam. Yes.
Perfect. Thank you so much. Thanks for giving me this opportunity. So today's session will be over the what is generative AI, the overview of the RAG, which is retrieval augmented generation, and the LLM models. So the agenda will cover the overview, large language models, the evolution of large language models, components of generative AI stack, prompts and completions, retrieval augmented generation, and data watch. So, to start with, what is generative AI? So, generative AI is basically a form of machine learning to produce the text, videos, images, and other types of content. It is basically a branch of artificial intelligence, which is we just pass on the prompts and we get to generate the text, video, image, any type of content we want. The basic examples are we all of must have heard chat gpts and some of us would already be using it, which has, I mean, taken up the market since it was launched. Chat GPT is being launched from OpenAI. We have other products from Google, Microsoft. So all these are which are dominating the market these days. We will cover up why these are so important and why are they dominating the market these days. So these are some of the examples which can be leveraged to produce the text, the images, the videos, the audios, all type of contents. Now, what makes the generative AI different from the traditional AI? So using the generative AI, you can create new data, the text, image, music, etc. Whereas with the traditional AI, it is generally to analyze the data, perform specific tasks on top of it. Generative AI is more data driven. It is based on neural networks, whereas traditional AI is basically rule based and algorithm based, such as the classification algorithms, the predictive algorithms. All those algorithms is on what the traditional AI is basically focused on. In generative AI, we are generating entirely new content based on either the pre-trained models or the trained models. In traditional AI, it is basically, as I mentioned, like the classification algorithms. So suppose you have a set of data where you need to classify into X and Y. That is where you can use the traditional AI. That piece of done work can also be done using generative AI, but traditional AI is solely based on that. For the generative AI, what is basic is the innovative chef creating the new pieces in the background. For example, sorry. Innovation is the base for the generative AI. In traditional AI, it is following a specific set of rules to create that recipe. So that is the difference between, if you compare, and if we need to compare the apple to apple comparison for generative AI versus the traditional AI. So generative AI is focused on creativity, exploring different possibilities which can be considered to generate the content, as the name in itself specifies, generative. Whereas in traditional AI, it is basically used for classification modeling, reasoning, basically supervised and unsupervised, all kinds of algorithms is what are implemented under traditional AI. But recently, we have seen a shift from the traditional AI to the generative AI, because generative AI is capable of doing what we were doing with the traditional AI as well. Therefore, so as artificial intelligence is still on the forefront of game changing advancements in the rapidly evolving field of technology, AI is frequently portrayed as a single idea. It actually has many subfields, each with the unique applications and the methodologies. Amongst these, Gen AI and traditional AI are particularly notable as essential different approaches that alter the way we work with the data. And you would also agree with me that this has changed our day-to-day working. I mean, almost every one of us is being somehow impacted by the coming of Gen AI dominance in the market. It can be used to resolve our issues, our daily piece of tasks, to produce new content, to write the emails, to share any kind of information, for everything. Sorry. So which industries are mostly being impacted by Gen AI? That is one of the question which comes is, I would say almost all the industries. So Gen AI affects pharma, manufacturing, media, architecture, interior design, engineering, automotive, aerospace, defense, medical, electronics, and energy industries and whatnot. It is being augmented in the core processes with the AI model. It will impact the marketing, design, sorry, corporate communications, and training, augmenting the support processes that spans across the organizations. It is believed that by 2025, more than 30% of new drugs and materials will be systematically discovered using Gen AI techniques. Gen AI looks promising for the pharma industries, given the opportunity to reduce the costs and time in drug discovery. It has also been predicted that by 2025, 30% of outbound marketing messages from large organizations will be synthetically generated, up from less than 2% in 2022. So, see the growth from 2% to 30%. Text generators like GPT-4 can already be used to create marketing copy and personalized advertising. In the manufacturing, automotive, aerospace, and defense industries, generative design can create designs optimized to meet specific goals and constraints, such as performance, materials, and manufacturing methods. This accelerates the design processes by producing an array of potential solutions for engineers to explore. Now, we have heard of large language models and language models, which play a significant role in Gen AI. So, what are large language models and what are language models? Language models are AI systems designed to process, understand, and generate human like language. They learn patterns and structures from datasets, enabling them to produce coherent and contextually relevant texts, with applications in translation, summarization, chatbots, and content generation. So basically, this is the text input. Here comes the language model, and this is the output. Now, generally, we use these terms interchangeably, language models and large language models. Large language models specifically refer to those language models with millions or even billions of parameters. And that is why they have been termed as large language models. The term large language models emerged in 2018 and 2019, coinciding with the introduction of models like BERT, which contain 340 million parameters, and GPT-2 with 1.5 billion parameters. However, the term became widely recognized following the launch of GPT-3 in 2020. And that is where there was a transformative potential of scaling with its unprecedented 175 billion parameters. So large, in as the term defines, it is because of the millions and billions of parameters, and that is why it has been termed as large language models. Now, using this Venn diagram, I would like to showcase you where this Gen AI falls under this whole AI and NLP. So NLP is has a part of it under AI, machine learning, and deep learning. So where you see this pink circle, right? Part of AI, subset of AI is machine learning. Then subset of machine learning is deep learning. And subset of deep learning is Gen AI. And it is also a subset of computer vision, NLP. And because deep learning is a subset of machine learning and machine learning is a subset of artificial intelligence, therefore Gen AI is a subset of deep learning, machine learning, and artificial intelligence. All. So it lies here in the center. So that is why it has made so much of impact in the industry. It has overlapping pieces with all the branches, basically. It's an intersection here. Now moving on, we understand like what is Gen AI and large language models. But we have been hearing about deep learning, large language models, and the foundational models. What is exactly the difference between the three of them? So deep learning is the broader family of machine learning. So we see here, right? So deep learning is a broader category under machine learning. It is based on the artificial neural networks with representation of learning. ANNs and RNNs were inspired by the information processing and distributed communication nodes. That is we call as a deep learning. Now, moving on to large language models. In the recent advances in the deep learning models to work on human languages, a large language model is a trained deep learning model that understands and generates text in a human like fashion. It is large transformer model that does all the magic. So basically, a trained deep learning model is a large language model. Now, what is a foundational model? So models trained on broad data that can be adapted to a wide range of downstream tasks. They are capable of range of person applications such as text, image, or audio generation. They can be standalone systems or can be used as a base for many other applications. Before we go ahead, we understand now what is generative AI and what are LLMs. Now, how they evolved over times, how they brought in the change in the industry. So it was in a step-by-step process. And this transformation revolution basically started from, I would say, 2017 onwards. So 2010 was being dominated by NLP models. Okay. Researchers were working on the NLP, natural language translations models that exposed to vast amounts of text being produced to get the better results. And it was more or less based on the grammatical rules. In 2014, sorry, they began to sense of the meaning of words in NLP by analyzing the context. So basically, the contextual piece appeared in 2014. But in 2017, basically the revolution happened. Advances made from 2017 to 22 resulted in language models that can serve as a foundation of the customization. Creating foundation models is cost prohibited, but once created, they can be customized using a small amount of additional data to achieve state of the art. So what happened in 2017? So there was a focus on a concept called self attention mechanism. So RNNs does not have self attention mechanism, but the transformer model introduced that, allowing the model to dynamically weigh the importance of each token. So what is a token here? So generally we have characters, right, in a content. But here, token is not a character or a word. It is their own defined terminology to consider the content characters. And you would have seen for every model, the cost is in terms of the number of tokens being used. There are limitations for the input tokens, the output tokens. So, um, it is relative to the other characters basically. Okay. So self attention mechanism enables the model to focus on the most relevant parts of the input for the current task. Thereby, it captures the context, semantic meaning of the information. This transformer revolution also brought in the multi-head attention. So what is multi-head attention? This mechanism operates multiple independent attention heads in parallel, with each head focusing on different aspects of the input. The outputs of these attention heads are concatenated and passed through a linear transformation layer, resulting in richer and more comprehensive contextual representations. So basically, this enabled to capture more complex semantic relationships. So here, with self-attention, we got contextual information. With multi-head, we got more complex semantic relationships. Then there came the feed-forward network and the layer normalization. This, along with the, it is basically for the connection. So each transformer layer contains a feed-forward network and applied for each token to have the connections between the residuals. So this revolution happened in 2017. See, so this is transformers in 2017. Then from 2018 to 2020, this is the era of the pre-trained transformer models. From 2018 to 2020, where came in GPT, BERT, T5. These were the kind of models which set up the era. So it brought up a new era in NLP characterized by the pre-trained models. So these were pre-trained models which could directly be used and consumed. It enabled the scaling also. And two of them, which were the most influential families of models, were the BERT and GPT. Then came Chat GPT in November 2022. And that is what set up everything. It was groundbreaking conversational AI model fine-tuned specifically for natural multi-turn dialogues. Post that, this has generative AI has been dominating the industry. Then came other models, GPT-4, GPT-4o, Llama 3.1, then OpenAI O1, DeepSeek V3, DeepSeek R1, which has recently been launched in 2025 January. So this is how the LLMs evolved over time. So transformer architecture in 2017 reshaped NLP through self-attention mechanisms. By 2018, the first two transformer-based LLMs, GPT and BERT, significantly enhanced contextual understanding. Sorry, laying a solid foundation for future innovations. In 2020, GPT-3 with 175 billion parameters demonstrated remarkable few shot and zero shot learning capabilities. But there was a problem at that time: hallucination. And what was hallucination? It was generating factually incorrect content. That was a biggest challenge. And therefore, in 2020, it didn't make that much impact compared to what it made in 2022. In 2022, OpenAI addressed this challenge by employing supervised fine tuning and reinforcement learning from human feedback techniques. So basically, in 2022, we got SFT and RLHF techniques. And that is how OpenAI overcome the problem of hallucination. It is not that hallucination problem is completely resolved. When we use the models like GPT-4 and 4o, still we land up with the challenges of hallucinations, but they are comparatively on the lower side. So basically, in 2022, this breakthrough sparked widespread global attention around AI. Then it picked the speed. By 2023 and 2024, multimodal models GPT-4 and GPT-4o came up, which seamlessly integrated text, image, audio, video, and all things now, which we all are using on our daily basis. OpenAI's O1 and DeepSeek's R1, which has been recently launched models, they are basically the reasoning models, and they bring LLMs closer to human-like system to thinking. Additionally, DeepSeek's models super efficiency. So the cost to build DeepSeek was really on the lower side compared to OpenAI. And their open source design challenge AI norms, democratizing access to advanced LLMs and innovation across industries. Now talking about the architecture of LLM. So LLM's architecture is defined by multiple factors like the specific model design, the computational resources make a big role, and the kind of language processing tasks that can be carried out by the LLM. It consists of many layers, the feed forward layers, embedding layers, attention layers, the revolution which transformers brought in basically, right? So main components are model size and parameter count, input representations, self-attention mechanisms, training objectives, computational efficiencies, decoding and output generation. Some of the popular large language models are GPT-3, which is developed by OpenAI and stands for Generative Pre-trained Transformer Model. And it is being widely recognized to generate the human-like text. Another known model is BERT, which was created by Google and is being commonly used for the natural language processing tasks, just such as to create the embeddings and all. Roberta is another advanced version of BERT. Bloom. It is a first multilingual LLM designed collaboratively with multiple organizations and researchers. Now, moving on to components of GenAI. What are the components in the generative AI stack? It consists of basically three components: the backend, which is based on the foundational model, the machine learning infrastructure; the tools, the developer prompt tools, security governance, annotation, performance metrics, embeddings, vector DB; and the application layer. Application layer is how the user uses it. It can be through a chatbot, it can be through a coding assistant, it can be through image generation, video generation, music creation, Q&A, anything and everything, whichever can come in the application perspective. I'll show you with examples. So in the backend, we can use the components of programming languages. So what is dominating as of now is Python, JS, and TS. Then comes the model providers. There are multiple organizations which provide to the access to the foundational models, while the inference endpoints, embeddings, and foundational models are typical models used in GenAI applications. So some of the companies which are dominating the market as of now are OpenAI, Google, Cohere, Meta, etc. Then there comes the LLM orchestrator and the framework. So what is a framework or an orchestrator? It is basically a library that abstracts the complexities of integrating components. Okay. So these are readily available libraries which can be reused. So operators within these components also provide tooling to create, modify, and manipulate prompts. Some of the model orchestrators and the frameworks which are dominating the market are Llama Index and LangChain. Then there comes the vector DB. Now, what is the role of a vector DB? So we all have heard a database. So similarly, to store the embeddings. Now, what are embeddings? Embeddings are the vector representation, numerical representation of the text. So we convert the text into the numerical representation, and then we save these embeddings into the vector DB. So there are models to create these embeddings itself. So some of the vector databases, for example, MongoDB, other open source vector databases, if I talk about, are ChromaDB, we have Redis. So all those are vector DB. Then the operational database, that is basically for the transactional and the operational data is what we need. It is not a necessary piece, but it may be required, it may not be required. But generally in the large applications, we do need an operational database because that is from where you source the information. Then there comes the monitoring and the evaluation tool. So tools for tracking AI performance, reliability, those where comes the monitoring and the evaluation tools. Then comes the deployment solution. So the solution can be deployed on the cloud platforms like AWS, Azure, Google Cloud. So that is where comes the deployment in the stack, AI stack. So that now we have covered what is generative AI, what are large language models, what is the stack, AI stack for generative AI applications. Now, how to implement it? We all must have heard, I'm very sure, about prompts and completions. But do we really understand what are prompts and what are completions? Prompts are the inputs, completions are the output generated by the model. Completion can vary in length and style depending on the prompt structure. So, when we ask anything, so suppose we are using Chat GPT. Okay, so where comes the language model? So we write a prompt, and that goes to the model, which creates the response in turn. And writing that prompt is the known as the prompt engineering. So basically, it is prompt engineering. What is prompt engineering? It serves the bridge, the gap. It is to bridge the gap between human intent and the machine output. So through prompt, we give what the human is trying to do. Language model will do what it is trying to do, and response is what is intended to do. So writing an effective prompt is very much required to get the precise results basically. So there are multiple ways to write the prompts. You may say methods or types of prompt. Prompt needs to be a well structured. The more well structured it will be, the easier it will be for the language model to understand the context of the request, leading to the better result, right? And I mean, it's right. The more clear your query is, the better response you get in layman terms. So that is how it is. The more clear your prompt is, the better response you will get. So now there are different ways of writing the prompts. First is zero shot prompting. Now, what is zero shot prompting? Where we don't give any prior examples to do the task. For example, translate the following sentence into French. Hello, how are you? I have not given any context behind it, right? Not neither any example, neither any steps. So that is zero shot prompting. What is few shot prompting? The AI model is given few examples to understand the task. So that is because in the term itself it says few. We are giving few examples. Zero, we are not giving any examples. The third method is chain of thought prompting. So in chain of thoughts, what happens is we guide the model through a series of logical steps to arrive to a conclusion. So for example, if the ask is, if John has 3 apples and gives 2 to Mary, how many apples does she have left? So what we are saying is, first count the apples John has and then subtract the apples he gives to Mary. Now it is divided into step by step, right? Series of logical steps. Therefore, it is known as chain of thought prompting. The fourth method is contextual prompting. It provides the background information or sets a scene to guide the AI response. We are setting up the background. We are giving the context. So for example, if I have to write for my client, I'll give the client background, the customer background. So this belongs to so and so company, they work for this field, this domain, and that is how you set up the context. So we started this session. So Hemlata ma'am set up the background, right? She gave the context. Now, who am I, from where, what do I do, what is my profile? So setting up that context. Similarly, we do it with a set of prompts. We provide the background. So, example, imagine a bustling medieval marketplace. Describe the sights, sounds, and smells you would encounter. So, here we are setting up the context. Imagine. Okay. So, that is how we do the contextual prompting. Then we have exploratory prompting. It encourages the AI to think broadly and creatively. So, for example, what are some potential impacts of telecommuting on urban planning? It's an exploration kind of thing, right? AI can think wide. So that is why we call it as exploratory prompting. Then there comes the directive prompting. We need to instruct the AI to perform a specific task. Or we give, for example, write a step-by-step guide on how to make a Japanese origami crane. So we are giving directive, do step by step. So that is how we write the directive prompting. Then there comes reflective prompting. Ask the AI to consider and analyze past experience. Reflection. So reflect on the importance of data privacy in today's digital age. What is it significant? So that is we term as a reflective prompting. Then there comes the compound prompting. You combine elements from different prompt types to create a multi-layered task. So that is known as the compound prompting. For example, imagine a future where AI can predict personal health issues, discuss the ethical implications, and then suggest guidelines for responsible use of this technology. Then there comes sequential prompting, a series of related questions or tasks that build up upon each other. Example: first, describe the process of photosynthesis. Next, explain how it impacts plant growth. So it is a sequence of steps. So these are different types of prompts: zero shot, few shot, chain of thoughts, contextual, exploratory, directive, reflective, compound, and sequential. So we generally follow one of these methods when we write the prompts. So once your prompt is written, okay, then you can query it. There comes retrieval augmented generation, which we call it as RAG. So it is taken from initials of these three terms, RAG. Okay. And it is a very powerful approach to combine the strengths of the large language models with the real-time information retrieval from external sources to help AI systems to give accurate, up-to-date, contextually relevant responses. It is tailored to specific queries, and basically it reduces hallucination also. Now, how does it work? So first step is retrieval. As the name suggests, user asks the query, it goes for the retrieval. Now from where it retrieves? It retrieves from the knowledge base. What is there in the knowledge base? In the knowledge base, we keep the embeddings. It can be the external, the internal. Okay. It will pick up the relevant chunks from here. Okay. Now I use another term here, chunk. What is a chunk? To pass on the content to the LLM model, you cannot pass the whole content. There are limitations in terms of tokens. So you split the content in small sections or segments. Okay. So those segments are called as chunks. In the retrieval, when the user asks a query, the relevant chunks from which the information can be coined, those chunks are extracted. And then the next steps comes in for the augmentation, where the prompts, which we discussed in the previous slides, plays the important role. Combined chunks with the prompt are sent to the LLM to generate the response. Okay, so that is how the response gets generated. Query, user asks the query, retrieval happens through embeddings. So what were embeddings? Embeddings were the numerical representation in terms of vector for the text, the content. So how you create that content, you pick it up from the external web through web scraping, or you pick up from the databases. It can be structured content, unstructured content. You create embeddings out of it. Embeddings can be created using the readily available models like TextAda of OpenAI. Those are all used to create the embeddings. And those are saved in the knowledge base from where the retrieval happens. Now, in the prompt, we pass on those chunks along with the query and text to generate the response through the LLM. And that is how we get the response. So that is the structure for the retrieval augmented generation. Now, if I need to make this work for a chatbot, how it works? RAG based chatbot. Okay. So user asks the question. Okay. How many index types does the latest version of Milver support? It will go for the semantic search. It retrieves answers to the question by performing a semantic search on the vector DB. Examples of vector DB: ChromaDB, Redis, MongoDB. right? So it does the semantic search, extracts the relevant information, and then we prepare the prompt. So that is the first part, right? Question with context generated from semantic search. R, retrieval, it is doing the retrieval. A, it is doing the augmentation. Okay, you need to answer the question using the additional context. User question you got from user, you got the retrieve content from the semantic search. So suppose you received n chunks or n documents. Okay, you augment them and then you send it to generation. G stands for generation. Gen AI model. What it receives is it receives the prompt plus the context to generate the answer. Okay. Now, once this is generated, it goes to the application layer to get the answer. So for the question here, sample question we took was how many index types does the latest version of Milvus support? The answer we got was as of last month, Milvus support 11 index types. So we got a reliable answer which got generated through this RAG methodology. When it was doing the semantic search, from where did it pick the information? It picked it up from the knowledge base. What can be the knowledge base? Knowledge base can be the structured information, the unstructured information, extracted from web, from DB, from document types, for example, PDFs, Excel documents, Word documents, all unstructured data, right? Which are where the content is extracted, the chunks are created. So for creating the chunks, you have certain readily available algorithms also, or you can do the customized chunking also. Okay. Once you have created the chunks, then you embed them and store them in the form of vector embeddings in the vector DB. Vector DB types, examples, some of the open source ones are Postgres. You have the enterprise vector DBs also. So for example, Redis, enterprise Redis vector DB. When you build on the scalable applications for the customers, right? Then you may not, the open source versions may not suffice because of the limited storage. Okay. Thereby you need to go with the enterprise versions also over there. So you can use the vector DBs as required and the cost effectiveness basically. So that is the whole structure, how the RAG works. Then coming on, so we have basically understood the overview. I mean, what is Gen AI, how it works, what is LLM, what are embeddings, what is chunking, how does RAG works, how LLMs evolved over times. Okay. And now I would just quickly want to give an overview. What are the top Gen AI use cases? Some of the top Gen AI use cases which are dominating the market are the customer service chatbots, Q&A basically. You can query anything and everything from the knowledge base basically. The automated IT testing, audio visual content generation, customer service supports, HR support, customer communications, business process flow management, document creation, IT security, marketing, text graphic generation, billing and invoicing. So the top of it is the chatbot, automated IT testing, audio visual content generation, customer service support, and HR support. These are the top 5 Gen AI use cases. And this is based on the ISG report of 2024. The Light blue ones requires high investment. The dark blue ones are the common use cases. And as I've already talked about, this has penetrated into any and every domain. Okay. It is reaching testing, HR, customer communications, documentation, in all the use cases that get most fundings are aimed at efficiency and profitability. Okay. We have also seen a trend that AI tools tend to be deployed in processes with a human in the loop to intermediate and validate the output before it is delivered to the customers. Where we have seen the practical outcomes as of now with the improved qualities are the better graphics, better responses to customer inquiries, better process mm, management, and to some extent better efficiency also. So one good example is we talk about chatbots, right? In the chatbots, you need to cover. So suppose a user has to go through 1,000 documents. So for a user to go through those 1,000 documents and then figure out a specific response, it would take hours, or I would say days, right? But using this GenAI implementation, that can be done in few seconds. Okay. And with the very, very good accuracy. And that is why it has brought up so much of boom in the market. It is reducing the efforts, it is reducing the cost, and efforts in terms of the man hours involved, right? When we were writing emails, right? It used to take minutes, right? Now we can just simply write, give the specifications, and get it written through Chat GPT or Copilots, right? Which are now being used by organization wides. This has brought in down the time. Okay. But as long as the use cases serve to augment the humans' ability to operate the process will still ultimately be a limiting factor, right? Because at, initially you will have to give that brief background to get that response generated, right? Therefore, that role still will be there. So overall, I would say to conclude that it has brought in a major movement, okay, in the market in terms of the response, the fast resolutions, and that is why the every organization has now started using GenAI across different use cases, and that is with which I will end my uh, thought and open for you all for Q&A. Over to you, Hemlata ma'am.
Uh, thank you, ma'am. If
Participants.
students, if you have any queries, you can ask. Okay, ma'am. It was a very informative session. Thanks, Mansi, ma'am. And now I request Glory, ma'am,
Okay.
for the
Thank you,
thanks.
Mansi ma'am, for such an enlightening and engaging talk. It's my privilege to propose a vote of thanks on this occasion. First and foremost, I would like to express my deep sense of gratitude to our management for their constant encouragement and support in organizing events that enrich our academic life. I also wish to express my gratitude to our principal Dr. N. Anbuchurian, and Dean Dr. K. Tyagarajan, for providing encouragement and giving us an opportunity to organize the event. Your guidance is always a source of inspiration for all of us. On behalf of our R.M.D. Engineering College, I would like to thank today's speaker, Ms. Mansi Jain, ma'am, Senior Manager Data Science, Cognizant Technology, for taking her precious time out of her busy schedule to grace these occasions. And thanks for delivering such an inspiring and thought-provoking thoughts on this topic. And I would also like to express my special thanks to our head of the department, Dr. P. Elmalai, who have been always been a pillar of our support to guiding us not only academically but also in organizing such wonderful events. Your tireless efforts and dedications are commendable, sir. And last but not least, I also thank all the head of the departments, faculty members, students for showing their interest in this program. I once again thank everyone who has made this event success. As we come to this end of this insightful sessions, I would like to extend my heartfelt thanks to everyone who joined us online today. And your participations and enthusiasm truly made this event a success. So we hope you found this session on this generative AI and overview of RAG and LLM as an inspiring and informative, as we also did. So we look forward to having you with us in upcoming editions of our Generic Talk series, where we continue to bring our engaging topics and distinguished speakers. Until then, stay curious, stay connected, take care. Thank you once again and have a wonderful day. Thank you all for joining with us. Thank you, ma'am.
Thank you so much, Glory ma'am. Thank you, Himlata ma'am, for giving me the opportunity.
Thank you, sir.